Are you running? Welcome to 445L. Here we are. I'm John Valdano, and this is going to be a fun semester. There are two demos going around. The one with all the wires picking up, it may not work by the time it gets to the third row because it's not soldered. But that's Lab 1, and I'll talk more about Lab 1 at the end of today's lecture. But push the buttons on the red launch pad, and it cycles through the various parts of Lab 1. The second is a prototype. It's actually two labs in one. It is your thermistor temperature lab, as well as your lab 6, 8, 11 built up into embedded systems. So you'll see a printed circuit board. You're going to design one of those, and you'll see a box. You'll build one of those, and you'll see a bunch of soldering. You'll bunch of soldering, and so welcome. This is a pretty exciting class. We have lots for you to do. We're still negotiating which TA is doing which section, although these sections will be taught in that particular order. There we go. I'm not going to read all of this. This is our contract. Let me just highlight some fun things on the syllabus. You'll get a board. More information about that, or this exact same information is up on Blackboard. You'll have wire strippers and access to a soldering iron. Lots of cool TAs. There's quite a bit of resources out there. The PowerPoints are going to be posted there. The labs are posted there. You can see where the labs are. I've worked on the first two. I'm working on the third one now. There's a number of resources that will get you through this class. What else is in here? What are we going to do? Before we do, what should you have learned before you got here? I'm not going to reiterate 319K, but there's some things out of 319K I expect you to know. Interrupts, C programming, the UART, the A to D converter, the periodic interrupts. We're going to start right off using them. This is after 312, so your sophistication in your C programming is a little better than it was in 319K. You'll know that I love my FIFOs and I love my structures. You're going to use all of that stuff from your 312. This is a bridge course in the same way 319K bridged the electrical engineering and the computer engineering. You will find that 445L is also a bridge class. When you look at the clear plastic box, about half of those chips in there are analog chips. So there's an analog reference, there's an analog instrumentation amp, there's an analog op amp, there's a power circuit. So there's 4 analog chips on that system, and not unlike what you'll see in lab. So this is a bridging class. So although 438 isn't an official prerequisite, your command of analog circuits is the following. You have to know algebra, okay? And if you know algebra and a couple of rules about op amps, you'll be fine in this class, okay? Ohm's law, etc. But it does have a significant analog circuit design component to it. I love to teach this class, even though I'm going to record it. I'd encourage you to ask questions, break in. Whatever. I'm happy you're here. Come to my office. Office hours are on here somewhere. I don't have my official room yet because we're still waiting for where I'm going to be in ACA. I'll do most of my office hours in ACA. The way to tell what it is you're going to learn in this class is to look at the laboratories. Lab 1 is, you don't have a lab partner, just go ahead and do Lab 1. It's basically an review of 319K and 312. You do some graphics program. You see the little star. Who's got the push the button until you see the star. That's the hard part of lab, is to be able to draw dots on the screen. Okay, so not that hard. The fixed point stuff is essentially your command of printf, and the rest of that is building circles and stars. We'll talk about the central limit theorem in Lab 2. We'll build an alarm clock in Lab 3. I decided to move the Wi-Fi up. It was such a powerful lab the last couple of times we did it. I thought we'd move it up Encourage you to put the Wi-Fi device into your project to make your projects an Internet of Thing. If you want, we'll redo the Lab 7 out of 319K where you've generated sound, except we'll do it for real. We'll do it with lots of bits. We'll do it with analog amplifiers. You'll create some music that actually sounds like music here in Lab 7. And then 6, 7, 8, and 11 are a cohort which become your project. So 6 is a practice. We'll build something and throw it away. And then 7 and 8, you'll design something. This is where this class is the most fun. So when you choose a lab partner, choose somebody who wants to do a project like yours and choose somebody who's working harder than you are. It'll make a big difference. Then we'll go back in 9 and 10 and get some more, some basic interfacing embedded system with making a thermometer and controlling a motor. We'll spin a motor using we won't use the D term of the PID controller because it's highly unstable and we got crappy sensors, but we'll use a PI. So that's essentially, if you look at what you will learn, it's what you do. And so that's, there's the lab schedule. It tells you when everything is due. There's my lecture schedule. You can see I'm pretty much ready for the first 5 lectures, but I'm working on it. What else is in here that you got to know? A bunch of legal stuff. We do look for cheating. Labs are pretty straightforward in terms of what's cheating. If you're erasing somebody else's name, that's got to be bad. Okay. So if you got lab solutions from last semester and you're erasing somebody's name off the top, or equivalently, they were too idiotic to put their name on the top and you just put your name, that's somebody else's code and you just put your name, that's bad. You and your lab partner work together. Other people in the class and previous classes are there for your helping, your understanding. But if you're transferring code in any way from another student, that's class dishonesty. Now, if you both download code from the internet and cite it, I got it from Texas Instruments, I got it off your website, Valvano, look right there, that's good. You're not taking my name off, so it's fine. If you're in trouble, get help. We got a set of TAs that are really awesome. I'm really excited about the TA situation. And I will introduce I might as well do it. I'm sorry, you're going to have to. Mahesh, okay, that's Mahesh. Young Chen, and I saw, Dylan in the back. We got one more working on it, and we'll announce that later. So go get help. Now, you can help each other. How does cystic work? Why did I get a hard fault? These are great questions to help each other, but my lab is due next week, and my lab is due in 5 minutes. Can I have yours? That's inappropriate. If you're unsure about cheating, ask. Okay, ask, because it's not supposed to be. Throughout this semester, you'll see I'll demo a logic analyzer. That's a $99 part from Digilant Analog Discovery. I really love it. Not required, but it's totally awesome. Bunch of free chips out there. We'll talk more about that later. What's the last thing I want to do here? You're probably going to see this over and over and over again, but we're supposed to tell you there's. Let me break down an emergency into two categories. Stay in the building or get out of the building. Okay, I don't know. The building's on fire. We're leaving. Okay, if somebody's out on the drag with a gun, we're staying inside. Okay, so. There's a bunch of websites out there. Basically, your phone should go off on an emergency, and then that will tell you what to do. That'll tell us whether to stay in or get out. So go ahead and connect your phones up to the emergency thing so that you know how to stay safe. And take me with you because I'll be clueless, okay? But like I said, there is, there's an official legal document. This is to prevent them from getting sued, I guess, if we get hurt. Because they have told us. I don't care about the legal thing. Again, if the building's on fire, let's get out. Well, let's get out. And if somebody's out there with a gun, let's stay inside. Syllabus, I'm done. Questions about the legal part? Oh, yeah. Grading policy. Everybody wants to know how to get an A. This is clearly not a weed out class. We've increased the percentage to the TAs up from 40 to 50%. That was Bard's idea, by the way. So, it's fairly easy to pass this class due to labs. It's fairly easy to learn something in this class due to labs. When we come up to the tests, I'll show you how to pass the tests. All my old tests are on the internet. They're not exactly the same, but I'm 62 years old and sort of been learning the little habits. And I will ask completely different questions, but who I am and what kind of questions I asked on the test are easy to predict. So very few people, everybody says the tests are hard, but nobody says, well, anybody who says, your test was unexpected, the next question is, did you study? And the answer is usually no. So if you study, you will not be surprised by my test. There's not a lot of surprise in it. The first one's closed book, the second one's open book, and the final is a combination of closed and open. So as you can see, well, by the time the end of the semester goes, we'll have 80% of our stuff done. Questions? And at any point you're curious about your grade, I got a 60 on this exam, what does it mean? Go ahead and ask. I'll try to give you a standard deviation with each test so you can see where you are. And if you go through the official channels, somewhere around 3.25, 3.3 is where the grade point average statistically has been over the last 10 years in this class. I don't care if it's 3.7. It probably won't be 2.7 because the TAs won't let that happen. They will hound you until your labs are done, and then you'll get a good grade. Questions about the syllabus? Yeah.
You mentioned PI and PID controllers. How much emphasis will this class have like on control systems?
Okay, the question was, we're going to leave the D part out because it's the derivative part is very unstable. But we're going to do a PID controller. He says, oh, did I have to take 362K? The answer is no. You need to know algebra. The amount of math in this class is really algebra. He's going to be fine. Algebra. If you have taken 362K or subsequently take 362K, this lab will make sense. This lab will make 362K make sense. If you're not a control theorist, it's sort of obvious. If you want to go faster, put more power in. And if you don't want to go slower, put less power in. I mean, it's sort of very intuitive. But the P term is a multiply. You got to be able to multiply. And the I term is an add. So that's how hard the PI controller is. Yeah. The hardest part about the control system will actually be the sensor interface. Will be the 445L part. Is how do you get the tachometer into a square wave that you can measure. Did I answer your question? Yeah, it's fun. That's what I said. This class is going to connect to other classes. That's my intent. Any other questions? All right. Okie dokies. All right, enough about the syllabus. Anyway, syllabus posted in the usual spots. Okay. Yeah. Okay, down. Click. All right. This is the board. It's the same one in 319K. If you have it, use it. If you don't, if you got the 120, anybody got the LM120? Good. Oh, you do. When you get to as opposed to the 123, when you get to that motor example, you're going to have to do the pulse width modulator different than the rest of the class. But I wouldn't. It's not worth $13 to buy another one. Just a little bit of difference. But there it is. Make sure you and your lab partner have each one because you will blow one up. The book, I don't care if you buy it used. There was a link on Canvas to buy it cheap. I don't care. Yeah, it's not. Sort of talked about the board. You can see the board going around. Lots of ways to buy the board. They're all pretty much equivalent. Mouser ships to me overnight free. I don't know. With the UT shipping address, Mouser is really pretty cheap. And a bunch of ways to get the ST 7735R. You will probably embed the graphics display into your project. So again, you might want to have two of those, one for each of you and your partner. I bought a lot of them over the internet, and it's all the ones that have the R at the end. I think it's the same chip. The one going around is actually one of the ones I got from China. If you want to do the first two labs on in simulation mode and order your display from China, I don't care. But this one is the full price one, and it gets there quicker. Any questions on the board? Yes. And all of this stuff we'll use again in the spring, so if you want to resell it, that's fine. 445L is, we've moved, as you know, the building went down. I think where we ended up was at least as good as where we used to have. The actual physical cubic feet is a little smaller. I do believe we lost some benches. I don't know, Mahesh, do you remember how many benches we used to have? 16 maybe? 16 benches, and now we're down to 10. What that means is your laptops will be critical. Virtually everything in this class you can do with your laptop anyway. But we're not sharing it with 445M this semester, so you know, this group in that spot. There are some times when senior lab takes over, but I think it will be helpful if you need access to an oscilloscope and the room is full. You can either go to the makerspace, which is going to have some cool stuff, and we'll talk more about that later, or here into UTA, well, over there, 1616 Guadalupe, in the basement. More about that later. And again, if you want to work completely at home and just come in and see your TA, this $99 logic analyzer is awesome. Okay. The directions for installing the compiler is the same one we used in 319K. So if you have version 4.72 or 4.73, that's all right. If you have version 5, you can also have version 4.7 together. All of my starter codes have been operated on 4.7. My laptop has both 5 and 4.7. It's a little bit trickier to get it to launch, but nevertheless, we're going to use 4.7. I'm going to show you this. I can show you this now. Okay. How many don't have the display? Lab starts next week and you don't have the display. A few. Yeah, most. All right. So one of your options in Lab 1, if you don't have the display, well, this is true if you don't have the display or the board, okay, is to run Lab 1 in simulation. So I'm going to go, once you go through the directions on this website and install the stuff, you will see a Launchpad DLL, which you're going to put into the wherever Kyle is installed arm/bin, and then this is my Lab 1 solution, and here's the I'm obviously in options, debug, and I'm going to select the simulator. Now, you used a lot of simulator stuff in 319K. It's the same simulator, but the particular connection point that you're going to use if you're going to do Lab 1 in simulation is the Launchpad DLL. The actual file is launchpaddll.dll, but in here you select that you want to use the simulator, and so let me go ahead and run Lab 1. So you do the usual stuff. You build it. Now you don't download it with the simulator because downloading it takes it to the board. All we do is debug. That's because we didn't pay any money. Okay, and now it opens up a bunch of stuff. Here are the switches on the Launchpad. Here, you see under Window Tools, Peripherals. Right here, you can see I can set up the Citronics display, which would be right there. And it's really just Labs 1 and 2 that will simulate. So if you have the device, you don't need the simulator. It's just if you somehow haven't yet ordered, you can see it runs a lot slower. Runs a lot slower than the actual board because it's simulation. but it's pretty accurate in terms of the ability. Now to go to the next thing, I got to push this button, push it, and then let go. Any questions on simulation? I think if you don't use the simulator all semester, that's fine. I'm demonstrating this at this point if you're all nervous. So lab start next week. What am I going to do? I don't have my board. I don't have my display. What I want you to learn is a review of 319K. And so you can do that equally well on the simulator. There's my circle. Push it again. There's my star. Okay. All right. All right. Questions? Oh, yeah.
Can we actually get the labs to work with version 5?
Okay, the question is, I love my version 5. I love my packs. You're on your own. He said, can I use it? And I say, yeah, sure, just don't. Yeah, there's nothing wrong with version 5. The simulator will not work in version 5, which is why we did that whole 70,000 kids on the internet doing 319K business. And version 5 came right out after we wrote the simulator, whatever it was in 2013, and it didn't run it was like literally a month before we were going to launch, and we did not upgrade to version 5. It's just like Windows 10, okay? Here, come on, between us, do you need Windows 10? Is it better, really? Yeah, no, but there is a version of Kyle which is better, I guess. It's 5.1 or 5.2 or whatever they're up to. We got stuck because the simulator didn't work. Yeah, it's just, I'll eventually come around. But you can still download 4.7. Yeah, sure.
So does the simulator work with the, say, if we program it with interrupts, timers?
Okay. Okay, so the question is, does everything work in the simulator? And absolutely not. Some of the peripheral readies don't work. All of 319K ran. So if you learned it in 319K, but the way we use A to D converter won't work, PWM won't work. Just labs 1 and 2 is without, so you can't do this class without the board. You gotta get your board. By the time we get to lab 3, you're gonna need the board and the display. Yeah, that was a good question. Lots of software. People tell me I'm an idiot, and they're probably right. And I'm not teaching you how to abstract. I'm not teaching you the right way to do embedded systems. There are 2 ways of thought. What the world does is they abstract everything, and they say, wouldn't it be nice if I had an interrupt, and I would like my interrupt to run at 1,000 hertz, and that's the extent of their programming. I make the analogy, it's like programming in LabVIEW. You bring up a box and you go solution, okay? What I want you to understand is what happens when an interrupt happens. So everything we do in this class will be register level I/O programming. There will be a register and there will be a number, and you're going to put that number into the register, and you're going to read the data sheet, and you're going to know why you put that number in the register. Nevertheless, once you graduate from the great University of Texas and go get out a job and you're working for real, you will then use the peripheral driver libraries of that processor, and you will ask for, may I please have a 1,000 hertz interrupt? I don't care how you do it, I just want it to be 1,000 hertz. That abstraction is called TiVoWare for our board. Okay? And we're going to use TiVoWare in Lab 4 when we do the internet, because when we get to the internet, it will be so complicated, you and I will not understand how it works. And so we'll say, please connect me to the internet. Please. There will be a let's go internet button, and somehow the magic happens. So except for Lab 4, there won't be any magic in what we do. But you should download it to see it. You're allowed to use it for your projects, by the way. I don't care if you use the abstraction for your project. The drivers are the board drivers are in there if you want to do that. That's a step for installation. The lab manual is on this first site. Some stuff associated with lab will be on the second side. Like I said, I think I got the first two done, and I'm working on the third. We'll use PCB Artists. Again, you're going to go, hey, Valvano, well, everybody else uses Eagle or Cadence or Pads or Ultiboard. These are all better programs than PCB Artist. What I have to do is I get 3 lectures to take a newbie. How many of you laid out a printed circuit board? Ooh, some. Yeah, well, the rest of them. Those who just raise their hand are going to find this that week boring. But the rest of you that have never laid out a printed circuit board, I get 3 lectures to take you from knowing nothing to laying out a board. And I got to tell you how everything. I got to tell you how the power regulator works and the clock works, and I got to tell you, and tell you how to run the layout program. And in order to get through that week, we're going to use a really simple one with no whistles, 1 or 2 bells, no whistles, and that's called PCB Artists. And so we will use it labs, 1, 2, 3, 4, 5, just to practice the circuit part. But when we get to 6, 7, and 8, we are going to, it will be required that we use it. If you're doing terminal stuff, you can use putty. Okay, here's the rah-rah part. Your happiness in this class has nothing to do with what I say. It has mostly to do with what you do, and second most, how good your partner is. And so at this point, I want to engage in the thought of the conversation we're going to have in 2 months when you're in my office and you say one of 2 things. I really like this class, and I'm going to go, if you could come into my office and say, I really like this class, I'm going to say, do you remember the first week and you had to choose a lab partner? What did you do right? Or you're going to go into my class and you're going to go, I really don't like this class at all. This is way too much work. My lab partner doesn't do anything. I have no idea what's going on. And I'm going to point to this week, and you chose a lab partner poorly. But luckily, 2 months in, 3 more weeks later, we get to say goodbye to that lab partner. You didn't marry him. You didn't go work for him. They're not your employee. You're not tied to equal opportunity, and you can't fire them or whatever. You get in 3 months, you get the 4.5 months, whatever the semester is, you get to fire that person regardless. So enjoy the opportunity of choosing a lab partner and jump in with eyes wide open and take notes. Did you choose a lab partner because they were honest, because they were hardworking, because they said what they did and they did what they said? These are all good things. They don't actually, a lab partner who's smarter than you isn't necessarily a good thing. Okay, you just want them to work harder than you. You want them to be nicer than you, and then you'll really enjoy this class. So here's my charge for lab partnerness: try to be nicer than your lab partner. Yeah, try to out nice your lab partner, and that means communication. That means integrity. That means hard work. That means helping them learn what they don't know, and so some of you are just saying, oh boy, I really like architecture, and some idiot made 445L a required class just so I can get into architecture, and you're just hoping to graduate and get through, and your project's gonna just be minimal. And, there's an easy way to get a B in this class. It doesn't take a lot of work to get a B. You want a B, make sure you have a shared goal your life dreams are to become into the embedded system, and you're willing to work a little bit harder. You want a lab partner with that same. Unfortunately, you got to be in the same lab section. And okay, I got another slide later. You got to be in the same lab section with that partner. I got a slide about how to switch later. Remember I said there was TiVoWare, which is the way the real world does embedded system programming, and then there's ValvanoWare, which is the register level discrete number right into registers. My starter files are there. Those should be downloaded. You should, in the process of doing the first two labs, look at these starter files, which are examples of how to use the graphics, how to do the I/O with the switches, how to generate interrupts, how to do this. These are all 319K review projects. These are not new topics, but these are review topics that you could look at in the process of learning. So we're going to learn how to read data sheets. When I lecture, when I teach something, I like to pop up the data sheet. And the question comes, how do I learn how to read data sheets? One way to learn how to read a data sheet is to take something you already know. Give me an example of a chip of something some electronic device that you understand how it works. An LED. Okay, you know what an LED is. That's a good one. Go look at a data sheet for it. You already know what's in there. So look at how they present the information. Give me another one that you probably know. It could be even simpler than an LED. A resistor. A button. Okay. There are data sheets for resistors, and there's a lot of stuff in there. You know what happens when you put too much power in, and how big is it, and all how the tolerances. And look at it. Buttons, op amps. But we're going to look at the data sheet for the microcontroller. It's going to be 1,000 pages long, and you go, but we're going to practice. We're going to practice that. There's a bunch of data sheets associated with the processor. These are the 5 that we're going to do. One of them's got the instruction set in it, what the assembly languages are. There's not a lot. Most of what we do in this class will be C. We'll need some assembly when we understand critical sections, which is a part of Lab 2. There's the full data sheet here with all the I/O devices in it. Yeah, there'll be stuff that you want to use that's not in the book. We don't talk about it. We'll need that. And every manufacturer goes, oops, it was supposed to do this, but doesn't. It does that. And so I'll warn you that it's not just TI that's flawed. It's every manufacturer will go, this is what it was supposed to do, and this one, and this is the mistakes that it has. And these are the things that don't work, and these are the workarounds for getting. The last one has the description for the particular little red board called the Launchpad. All right, so as I said, TA, you have to be in the same section as your lab partner. In previous semesters, we sent you to the advisors. I'm going to try something a little bit different, and that is either after class today or before class on Friday. If you would like to change sections, why don't you meet up in the front and use the board and try to figure or use Canvas or whatever. And once we identify 4 people labeled in my thing here, A, B, C, and D, A wants to partner with D, B wants to partner with C, but they're not in the same section. Then we will unofficially swap B and D so that A and B and B and C can be partners. Now, if you want to officially swap, that's fine, but suffice it to say, you have to get in line with an advisor. But you do have to be in the same section. That keeps us from having 20 in one section and 2 in the other section. If you want to switch and don't yet have a pair, you might just go right to Canvas or meet after class. Any questions on switcherooing? I don't know. I have not looked to see whether that new section, that 21 section, is filled yet. I don't know. If anybody looked at we added a new section just last week. So last week there was a section with 0 people in it. But then there was a waiting list, so. All right, so I'd like to do a demo. Is it is the thing going all the way around? Where's the red one? Yeah, bring it up front. Let me do a demo. Yeah, that's my last one. now the slide pod in this circuit is actually my demo for lab 2. This was it running in simulation. Let's quit that. Go back over here. Projects. Okay, project options. Where are your options? Okay, options. That one. Debug. Yeah. All right. So here I am in the compiler. There's one of the things I do when I develop software is write a bunch of main programs, and the main programs are just to test things. Like main program 5 is just testing my delay loop, right? And so what's supposed to happen if I were run main program 5 is it toggles the bit, as you can see, once a second. So the light should go on and off once a second. And you go, hey John, main program 5 is not much 4 is not much different. That's once every 10 milliseconds. Let me go. Okay. So when we write drivers, there will be 3 components of a driver. One will be the most important one. If you're dividing up a project, take the H file. And so if you look at a project, for instance, here, if you look at a project and you look at the graphics, component, the H file associated with the graphics, this one, has all the cool design in it. This is the design of the interface. The interface has a description of what it does. Okay, how I draw a pixel, what the parameters are associated with this. It's prototypes for the public functions. And so this is the most fun part about a design, is designing it, architecting how this I/O will work. Okay? And so you're going to add a few extra parts to this already made library here in Lab 1. And then the second file is the C file associated with that. This one is fun, but it's this is the actual working. This is the hard work part. The other was the fun part. This is the hard work part where you figure out how to make it happen. This is a you know what static means? How about an easier one? Somebody tells me what void means. No return value. Okay, that's what that means. Do you know what int? Do you know what int 8t means? Unsigned 8-bit integer. Okay, 0 through 255. Now that's C99. Okay, we're going to use C99. Anybody like my name? C? Somebody say no. It's not a very good name. Give me a better name for the parameter. Command. Yeah. You know, it doesn't run any slower if I make it 7 characters long. The whole point of the names is make it easy. But you probably can tell me what the function does. Writes a command. Okay. Yeah. Writes a command to where? Well, obviously to the graphics thing, because that's in the graphics thing. Inside is how it actually works. That's the SSI. We're actually going to learn how this works later in Lab 5. But static means that this function is private to this file. Okay? So this function is not public. No other function outside of this file can access this function. So it hides the existence of this function. In the same way in C++ you used private, and so it's a private function. That's what we do in C. So a static function is one which it cannot be called from anywhere else. And so then the third file associated with the driver is the main programs, and it is how it is we're going to use this function. So these are example use functions for, in this case, the graphics driver. And so we're going to initialize the phase lock loop. That's line 97. We're going to turn on all the lights and switches of the launch pad. That's port F. We will connect or initialize the graphics display. Again, the only one that I know works is the ST7735R. And then there's a couple of different R's out there. All the ones I've seen use red tab, and I don't know what red tab means, but those are the configurations for initializing this device. You can tell it's a good driver if it doesn't require any comments. So, for instance, this line of C code is not very good because it required a comment. Well, you know what it does because there is a comment. Okay? So somebody tell me how this would have been better written without the comment. What could I have done to make this better?
Instead of saying fill string, there's a black string.
Yeah. Or that's one way. I could have made a fill with black as a function. Sure. I like that. What's another way I could have made that better?
I could just write a macro, like define black.
Ooh. Yeah, you see that? He's a smart man. I love this guy. There are two ways to make this better. One is to define a define statement. You call it a macro, that's right. That said pound define right? Right? Because the best code has no comments. Okay, comments should be used when you can't make it clear. You have to explain what it is. Anybody else? Any other way it could have been done? Even better than a pound define? Enum. Yeah. The trouble with pound define is untyped. Okay? It's not, I could have put in, a baby kitten in there. Right? Baby kitten equals 12. And I could have passed in a baby kitten. But if I make enums, I can make it specific for this. It's even a tighter one. But look for ways in which I'm imperfect in my starter code, for ways in which you look for ways to make things make things better. The second thing going on here in this main program is how to test. Okay? In the main program built into the design of the main program is how it is I'm going to test it. Okay? And it went around, and I ran it also in the simulator. Can you get a sense of how it is I tested this? The function you're going to write is this one here, which is going to output a signed fixed point decimal with 3 decimal points. But how did I test it? Did you see how I tested it? Look at the line right under it. I call your function, or you call your own function, and then what do you do right under it? You call what it's supposed to be. So if you look, outstring is something that already works, that outputs a string, right? It could have been printf, but it outputs a string. And you look at what it's going to output, right? Right? So it's going to output, it's going to input, it's going to pass to your function a 0, and then you're going to output whatever you give it, and then it's going to output, hey buddy, it should have been 0.000. Okay? Now, yeah, if it were stronger, it would have actually had a camera or somehow actually tested to see what it would output. But you can see when this works, the 2 columns will have the same values. Does anybody know what the word coverage means? What does coverage mean? Okay, coverage is a testing word. Okay, and he said it does every line. Okay, give me another definition. Well, okay, I'm testing. He said, clarify the question. All right. So let me clarify the question. You are writing this function called ST7735 underline S aLec S3. Okay? And I want to know, relative to testing the validity of this function, what is its coverage?
The test case.
Yeah, the test case. So if you look at the way this function is prototyped, how many possible, in fact, let's go, let me find where I put it. I think I put it in here. Yeah, there it is. There's the prototype for the function that you are going to write. Now you can change the prototype if you want. I don't care. But you still got to write a function that does something like this. But there's the function you're going to write. Okay, so tell me how many test cases there. If I wanted to test them all, you know, like the first 151 Pokemon, if I wanted them all, I want to catch every one, how many things should I have tested? Yeah, it's 4 billion. Right? There are 4 billion possible numbers that could have come into this function. Okay? You see that? And so the coverage that I had in this lab were these 13. Okay? I tested 13 out of the 4 billion cases. Okay? Good enough for lab 1, probably not good enough for the space shuttle, right? So, but that is what's inherently going on. This is a way for testing. So the main program, okay, so I'm done chatting about what it is. Let's run it. Build. Yeah, it turns out there are. It turns out that there are some colors. Right, there were some defines already up there. I just forgot to use them, by the way. But nevertheless, okay, so build, download. I'm obviously plugged in at this point. No errors. That's good. Hard faults are bad. All right, debug. Now the windows are different. Now I got to look at the display. I got to use my voltmeter, etc. Okay, lights stuck here. There it is. Run. Yeah. All right. So it ran. That's the thing that was going around. So you can single step, you can break point. These are all things that you want to learn how to do. All right. Okay, Alt Tab. Now push over to the display. So in summary, what did we see? We saw this class is a bunch of labs. We'll do the Internet of Things. We'll build a printed circuit board. We'll measure temperature. We'll control the motor. We'll build an alarm clock. We'll play some music. Pick a good lab partner. Okay, either if you want to switch sections, go up here. Go to lab next week. Right? There's no lab this week. Those of you that are Monday, Wednesday, miss a lab because of Labor Day. And we will see you on Friday. Thank you very, very much for signing up.